All right, so continuing looking at the classifications of numbers, now given a number, let's classify it with its appropriate categories. So you'll see on the top of the screen, which is at the bottom of your notes, here is the shorthand for these numbers. It is off center, so the bolded N goes with natural numbers. Whole numbers are that fancy W. Integers are Z, rational numbers Q, irrational S, and then real numbers is going to be that fancy R. So just some shorthand for that. I will use the also the shorthand, but then I'm also going to use the actual words above it, like in the chart on the screen. So the example says, complete the table by placing check marks in the appropriate columns. So what we're going to do is, if something, let me go back to our chart from the last video. If something is a counting number, it's also a whole number, it's also an integer, and it's also a rational number. That's why these circles are drawn within each other, because a number like 2 most specifically is a counting number, but 2 is also a whole number. 2 is also an integer, and 2 can also be written as a fraction, 2 over 1. And so that's why we're going to use this table, because we're going to check all that apply. So let's first look at the number 2 over 3. So that's a fraction, already written as a fraction, so I know that it will be a rational number because it can be written as a ratio. It is written as a ratio. Well, it's not an integer because it's not on my number line. It's not on a standard number line. It's not a whole number. It's not a counting number. And certainly it's not irrational because it is a terminating decimal, 0.5. Everything in this class is always going to be a real number. Just remember, that's all of these numbers are real numbers. And if you took algebra, you did learn what imaginary numbers mean. Those are the not real numbers. We're not covering that at all in this class. So everything's going to be real. All right, the number 12. 12, if I go back to my chart, 12 is a counting number. If I extended this out, I would get to 12. It's also going to be a whole number. It's also an integer, and it's also a rational number. So 12 is an example of almost all of them. It's a natural counting number. It's a whole number. It's an integer. It can be written as a fraction, and it's a real number. It's not irrational. Remember, irrational is my pi, square root of 2, non-terminating, non-repeating. -7. Most specifically, my negative numbers fall right here in the integers. If I were to extend that out, I would get to -7. So it's just an integer, but then it's also a rational number. So it's an integer, a rational number, and remember, they are all real. 4.2, or 4 2/10. Not a natural number, not a whole number, not an integer. It is a rational number because it's a terminating or a repeating decimal, and it's definitely a real number. Square root 16. Well, they tried to trick us, but the square root of 16 is actually 4 because 4 squared equals 16. And so 4 is a natural number. 4 is a whole number. It's an integer. It's a rational and always a real. 2 3/5. Well, it's got a fraction in it, so it's a rational number and real. 0.314 repeating. I know that's a little hard to see, so I'm going to write it. That is a repeating decimal which could be written as a fraction. Remember, we said you put it over that number of 9, so that'd be 314 over 999. And so that is a rational number and always a real number. Negative pi. Pi is prime example of the irrational. I cannot write pi as a fraction. If you type pi into your calculator and you try and convert it to a fraction, it's going to keep giving you back the same decimal, but it is a real number. And then square root 7, that's another one. Let me switch back over to my calculator. Square root of 7 gives me that crazy decimal. It looks like it could start to repeat there with all those ones. So if I wanted to check it, I would say math, enter. Nope, it keeps giving me back the same the same decimal. So I know that that is irrational and always real. All right, so now we're going to zoom in on just square roots. And so square roots are because if you were to use that number of blocks, you could make them in a square. The length and width would be the same. And so a square root is a number squared equals whatever. We'll just say triangle. So square root of that number, triangle, would equal the number. And let's change these colors out so it makes it a little bit less confusing. So if you take a number and you square it, if you square root that number squared, it is the number. And I know that that's a lot, but let's look at it with actual numbers. So the square root of 9, because what number squared is 9? Well, 3 squared is 9. We could say that the square root of 9 is 3. Square root of 25, well, what number times itself would give me 25? What number squared would give me 25? 5 squared would give me 25. So the square root of 25 is 5. And so in general, the square root of a number squared, like the square root of 49, oops, that's not what I wanted. The square root of 8 squared, well, this 8 squared would be the square root of 81, sorry guys, 64, square root of 64, and then that would be 8. So we can see that the square root and the squared actually cancel each other out. They are inverse operations. So the square root of s squared is s. And that's true of variables. That's true of numbers. And so both answers have been positive, 3 and 5 for letters 1 and 2. These are called the principal square roots. The principal square roots, spelled that wrong. Principal square roots would be the positive square root. So most of the time that's what it's going to ask for, and it's specifically going to say find the principal square root. But it's also true that the negative number times themselves would be positive. So in the square root of 9, negative 3 times negative 3 does equal positive 9. So technically the square root of 9 is both positive 3 or negative 3. The square root of 25 is both positive 5 and negative 5. So to clarify, we will say write the principal square root, which is the positive 1. Now let's look at, still in square roots, but let's look at some irrational numbers. Irrational are going to be numbers that cannot be written as a decimal or cannot be written as a fraction. They are non-terminating and non-repeating decimals. So pull your calculators out. Square root of 19. So the square root of 19 is going to be that number that you see on the screen. And I'm going to round that off to 2 decimals. So 4.358 is going to round to 4.36. And then the square root of 115. $10.723805, round off to 2 decimals, 10.72. And then the last one, square root of 85. Round to 2 decimals is going to give me 9.22. And so in general, if the answer to the square root of s squared isn't a whole number, then the number is an irrational number, like those up above, because they will give you a non-terminating, non-repeating decimal.